Let's take a look at an example of finding a horizontal tangent line to the curve of a function that involves a trigonometric function. So we want to determine the points where the function f of x equals the square root of 3 times x plus 2 times cosine of x, where we're limiting the values of x to lie between 0 and 2 pi, has horizontal tangent lines. When we are looking for horizontal tangent lines, we are looking for where the slope of the tangent line is equal to 0. So this means we want the slope of the tangent line to equal 0. And we know that the derivative of the function gives us the slope of the tangent line. So we're looking for points where the derivative is equal to 0. Now keep in mind, we are limiting our area of interest to the interval from 0 to 2 pi. So let's go ahead and find our derivative. So f prime of x equals, we're going to be using the sum rule and the constant multiple rule. Notice that square root of 3 is a constant. So when I take the derivative of my first term, that square root of 3 becomes a coefficient times the derivative of x, plus, and then the 2 also, constant multiple. So 2 times the derivative of cosine of x. So taking the derivative of x is 1 by the power rule, plus 2 times the derivative of cosine is negative sine of x. So we end up at our derivative being square root of 3 minus 2 sine of x. So that's our derivative, but what is our goal? Our goal is to figure out where our derivative is equal to 0. So now what we want to do is to take our derivative, so f prime of x equal to square root of 3 minus 2 sine of x, and we want to solve an equation. We want to know where that is equal to 0. So we can go ahead and add 2 sine of x to both sides of the equation. So we get square root of 3 equals 2 sine of x. We can divide by 2 and divide both sides of the equation by 2. We get square root of 3 over 2 equals sine of x. And now the question becomes, for what value of x, what values of x, is sine of x equal to square root of 3 over 2? And remember, we're looking at the entire interval from 0 to 2 pi, or you could think of it as we are looking on the entire unit circle. Now in calculus, all of these rules for differentiation, for integration, are based on the assumption that we do work in radians. So when I am looking for the values of x that produce a sine of square root of 3 over 2, those values of x are in radians. And so sine of x is equal to square root of 3 over 2 at pi over 3 radians and at 2 pi over 3 radians. And so remember, this was asking us to find points. At this point, all we have are the x coordinates. We do not yet have points. So let's go ahead and find the actual points. So f of pi over 3 is equal to square root of 3 times pi over 3 plus 2 times cosine of pi over 3. And so we end up with square root of 3 pi over 3 plus 2 times, and now cosine of pi over 3 is 1/2. And so that will simplify, the 2 times the 1/2 will simplify to be 1. So one of our points is pi over 3, comma, square root of 3 pi over 3 plus 1. And now let's figure out the y-coordinate for our second point. F of 2 pi over 3 equals square root of 3 times 2 pi over 3 plus 2 times cosine of 2 pi over 3. So this is 2 square roots of 3 times pi over 3 plus 2 times cosine of 2 pi thirds. And cosine of 2 pi thirds is negative 1/2. So that will simplify with the 2 coefficient to become a negative 1. So we would end up as our second point, 2 pi over 3, comma, 2 square roots of 3 pi over 3 minus 1. Now, recognizing that the question actually asked for points where the tangent line is horizontal, our answer should be these ordered pairs and not simply the x locations of those points. I hope this helps.